Hello? Hello?
Yes.
How are you doing?
Good, and you?
Fine, thank you. So who is TMO? Okay, it's Taki, okay.
Oh, Dijon Dunson. I don't know why it does that. I gotta rename it.
So what's your name again?
Dijon Dunson.
Good evening, Professor.
How are you?
I'm fine, sir.
I'm trying to figure out who this is. Oh, Dijon, right? Dijon. Okay, I see. All right, let us begin. Today we'll begin a new topic. Oh, hold on, let me close this. Close this.
Did you end the meeting? Did you end the meeting accidentally? Because it said the host.
No, it's connection.
Oh, okay.
It wasn't. I wasn't hearing the speaker, so I ended it and began a new one.
Yeah.
All right. Today we'll be looking at normal distribution. Last yesterday we did probably binomial. Today and tomorrow we'll be doing normal distribution. Now, many variables, continuous variables, especially things like temperature. We have what we call normal temperature of the body, you know. So anything above that normal is not normal. For example, if you go to some places now, some offices, government offices, before you enter, they will take your temperature to see if it is the normal body temperature. So if it's not normal, then they suspect something, you know. So we know what is normal, what it is good for in the majority. Now, how about this height? People's height. Somebody who is already 18 years and above, there's certain height we expect the person to be, you know. Then if it's not within that height, then something is, that means that person is not within the normal range. Or if the person is too tall, that means it's above average. But there's a certain height we expect an adult to have, you know. Now, how about this? Let me use the salaries of teachers. Depending on the county. There's some counties that pay teachers up to $60,000 a year. Some county pays even up to 70, depending on how rich the county is. Some pay 50 a year. Now, but if you see a teacher that is making $150,000 a year, that is not the normal range of salary for that average. So there are certain things that we expect that are normal. So for those kind of variables, they have a distribution that are bell-shaped. They are shaped like a bell, like this one here. Okay? Shaped like a bell. So we call those distributions normal distribution. Can you see the screen? Can you all see this? Okay, good. We call those distribution the normal distribution, or bell-shaped distribution, or Gaussian distribution. They are named after the German mathematician that derived it. So the normal distribution can now be defined. The normal distribution is the continuous, symmetric, bell-shaped distribution of a variable. Now, we use it to describe so many, the variables that are, because many variables actually, because the difference are not that much. And this is how, I'll give you another example. If I come to this Baltimore and say, okay, let me check the heights of all the ladies, not young people, I'm talking about ladies in Baltimore. let's say 20 people, it will not give me a smooth curve like this. It will give me, curve that is not as smooth as this. But if I plot the height of all the ladies, mature ladies, those that are above 18 years and above in Baltimore, it will give me a smooth curve like this. It's normal. Now, let me give you more examples. The normal range of systolic blood pressure is 110 to 140 millimeter of mercury. Above that, it's not normal. And below that, it's not normal as well. How about this? Normal interval for a person's triglycerides is from 30 to 200 milligram per deciliter. So above that, not normal. Below that, not normal. How about birth weight of a baby? Usually 6 to 9 pounds is the normal range weight. Below that is an underweight baby, and above that is overweight. And I can give you as many examples as possible. With this, we can now look at the properties of the theoretical normal distribution. One is that a normal distribution curve is bell-shaped. You can see right here, it is shaped like a bell. See? Yep. Now, the second one says the mean, median, and mode are equal and are located at the center of the distribution. So you can see right here, the center right here. This is where you have the mean, median, mode. See? Mean equals median equals mode at the center of the distribution. The third property is this. The normal distribution is unimodal. It has only one mode. See, the tallest part of the distribution, do you see? That's the mode right there. Okay. Then the curve is symmetric about the mean. So it's symmetric. It's half of this. It looks similar to half of that. So they look alike. You can basically fold this curve, this chart from here, and they will just fit in. The curve is continuous. That is, there are no gaps. So it is continuous. That's, no gaps. See? Okay. The curve never touches the x-axis. This is the x-axis. You can know from your algebra class, and this is the y-axis. But we don't normally draw the y-axis because we're not interested in the y value. We're looking at only the area. So we just use the x-axis. But see, it doesn't touch the y-axis. Keep going closer to it, but doesn't. That's why they call it the asymptotic tail. Never touches. This part is called a tail. This is the right tail, and this is the left tail. The total area under the normal distribution curve is 100%, which means that the total area for this, usually half of this is 0.5. The other half is 0.5. So that total area becomes 0.5 on the left side, left half. Then 0.5 on the right half give us 1.0. Or if you like, and call it 100%, because it is a probability. See? So that's basically summarizes the area of the theoretical normal distribution. Any question before I continue? Any question? Okay.
No.
Go ahead. So no question there. Okay, good. Now let us see how to find the area under the normal curve. The process is, first of all, to draw the curve for the equation you're trying to find the area. Once you draw the curve, then you can use this table. Remember I told you about the table that we'll be using from now on. So we use that table. See this table, before this one is table 4. Excuse me. This one is table 4 for binomial. So we can't use this for normal. For normal, it's table 5. This one here. You can see table 5, area of a standard normal distribution. Let me tell you something about this table. There are two different types of table, two different versions. This one, which is not cumulative, and there's another type that is cumulative. Now, if you know how to use both of them, you will get the same answer. Now, the rules that for using this one is a little bit different from the rules for using the cumulative type. So I recommend that you stick to this one since the time is very short and you don't want to get yourself confused. So stick to this one that we're using here. However, if you know how to use the other type, you can also use it because you get the same answer. So you can see the Z and then Z is right here and so on and so forth. Now, so once you draw this chart, you look for the Z value on the table to get your area. Yeah. Let's try the first one. The first one here says, find the area under the standard normal curve which lies to the left of Z 1.76. The first thing is to draw the curve of Z 1.76. Okay. So once you draw the curve, you can now put this in. So I'm gonna put it right here, put 1.76, 1.76. Then I'm gonna draw the curve by inserting this. Okay, I'm gonna go this route. Okay. Well, I'm not too good at drawing, but I'll try. Okay. All right, remove this one, this part. All right, let me draw it again. I'll go there and go this route. Okay. Right. Now, then I'm gonna draw the x-axis for this one. From here to here. And say to the left of Z. So let's see, let me put the center first. You always put the center first. The center is 0. Okay. 0. And Z 1.70 is positive, so it's gonna be on the right side. And it says you put the line that will represent 1.76. Okay, right here. So, and it says to the left of 1.76, from here, going this way is the left. So you gotta share that part. Okay. Share the setting is the difficult part. But if you're drawing it with the paper, it's basically easy. Do that. Sometimes you can use dot to shade it, but that will take a longer time. So you're looking for all the area, we say to the left of that, to the left of Z 1.76. So this shaded area are what we are looking for. The area that they represent. Okay. And so on and so forth. Okay. All right. I think 2 more and we are done with that with the shading. Okay, 1 more. So all these shaded places represent the area to the left of 1.76. If you remember, I told you that it is 0.5 on the left side and 0.5 on the right side. So now, having shaded this, the area will become the whole of the left side plus this side. So that the area you are looking for, the area, okay, I see. Let me see what I can do. And the area becomes equals this 0.5 as half of this, which is 0.5 plus now, and this part starting from 0 to 1.76. This is the area you look for in the table. So you go to the table at this point, you go to the table and see 1.76, 1.7, see 1.7 right here. So, and you're gonna go under 6. So 1.7, you go under 6. Okay, you can see right here, see under 6. And that is 1.7. So 0.4608, 4608, 0.4608. 0.4608. We add this, you get the area that is on the whole of the left of 1.76. So the area becomes, you add this in the calculator. That's my pen, let me write this down. Yeah. 0.5 plus 0.4608. So 0.5, which is 0.5 plus 0.4608. Like 0.9608. So you have it 0.9608. 0.9608. Or if you like, I can call it 96.08%. So area to the left of this number is the whole of this place, which you find on the table, and this 0.5 of the other half. So if you add them together, get this. Questions? Any question on the class?
Hello.
Yep.
You don't have to round the 1.76. You don't have to round it up to like 1.7.
No, it's already rounded. We stop at the second decimal place, which is 76.
Okay.
So, any other question? Okay, good. No question. Okay, good. Now let us try part B. Remember this, the one we did to the left of it. So remember, always draw the chart first, because the chart will tell you what to do. For example, here the same 1.76, but we are looking to the right of it. So we have solution. Have 1.76. Center at 1.76. Okay. We're looking to the right of it this time. So let's first of all we draw the chart. Okay, we start from here. Okay. 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 Right. Now we can draw the x-axis part of the chart. Okay, put here and yeah. Then put the center of it. Now, is to the Center is the mean is center is here is 0. Now, then we draw the, say this is 1.76. If 1.76 is negative, it will be on the left side. It's on the right side because it is positive. So we have this 1.76 line, the line that represents 1.76. That means we're gonna move it back a little bit. Now it says to the right of it. That means this is the line that represents 1.76, and this part is the right of it. So we share the right of it. This is the right of it. Okay, this is the right of it. Okay. The drawing part is the more, if I do it on paper, it's easier. Now there might be some graphing software that you might use that give you the shading from a single click. Unfortunately, I don't have that kind of software. But as long as you get the point I'm making, that's the most important thing. Okay, you get the principle and the points, the rationale, logic. Right. So when it appears like this, we call it the tail. Tail. So we call it this the right tail. So this is the tail. Whenever you occur at the tail, it can be, this is the right tail. It can also occur at the left tail. Okay, I think I made a mistake here. Oh, left tail. If it's on the left side, we call it the left tail. Left tail. See? Now, in that case, remember, this is half 0.5, this is 0.5, but you're looking for only this portion. In that case, the area will become, so to get only this portion from geometry, you can know that 0.5 minus what you got for this. So that the area, whenever it's at the tail, even if this tail occur on the right side, this is what you're gonna do. So long as you're using this table that I'll show you, 0.5 minus, now whatever thing you found for 1.76 on the table. I can go to the table. We can use what you already found for this because it's gonna be the same thing. 1.7 here, you go under 6. That is the same thing we had before. 0.4608. 0.4608. 0.4608. When you do this in the calculator.
I'm sorry. How do you know to look at number 6? And
How do I know what?
how do you know to look at number 6? I know why you looked at number 1.7, but how do you know to look at 6 in the table?
Yeah, because the first one, the first two, 1.6, 1.7, 1 point anything, you get that is the first part of the Z. You get that from the left side of the table, which is here. The last digit you get from the top, which is 6.
Oh, I got you. Thank you.
So, going back, we can now see we can do 0.5 minus 0.4608. We can get that from the table. I'm sorry, the calculator. 0.5. 0.5 minus 0.4608. Give me 0.0392. 0.0392, or if you like, you can call it 3.92%. Yeah. Percent. Oh, I'm a mistake, percent. Now, Remember, this rule is for this table. The other table, which is cumulative, have a slightly different rule. If you're using that table and you apply this rule, you get a wrong answer. So if you're using any table you're using, make sure you know the rules for that table. I recommend you use this one that we're using here because the answer will still be the same. And also because we have very short time. Next week will be our last week. And then we enter exam week, I believe. Yeah, next week is the first week of August, second week of August. Okay, we still have second week of August, but that will be the ending of the semester. So stick to one so that you can get this done, and then we go from there. Any question from the one I just did?
Nope.
Good. Now, next one is this one. It says to find the area between z negative 0.87 and z 1.28. Solution. In this case, they give you two values. Okay, two values. I hope this place will be enough. One is on the left side, which is negative. If you're using this table, you will notice that this table doesn't give you anything for negative. Why? Because if you're using this table, you assume that the normal distribution, which is one of the properties, is that it is symmetric, just like your left side, right? So whatever is right side and left side, they'd say the same. So if you're using this table, the negative value is just there to show you that you are talking about the left side. That's all. So you don't have to worry about negative sign. Just when you see negative z value, it means that it's on the left side. So you have negative 0.87, and of course we have a center which is 0, and we have 1.28. So it's 28. So let us draw. I think I went too far. Okay, I'm gonna bring it back closer. Anyway, let's draw it. We draw our chart. I think it's going to go this way. All right. Okay. Okay. Now we can make our center. So I'm going to go back a little bit. So we draw the x-axis. This is a center right here. Where the mean, median, and mode are located. Okay. Now, for the left side, we have this shape here. Okay, that is 0.87. And for the right side, we have 1.28. 1.28 would be a little bit further, so I'll reduce it. Okay, now we say between them, between these two values, so that we're going to share between these two values. Okay, we share it. All right. Sharing the two values. Okay. Right. See between them. So you can see why it is important to draw the chart first, because that will show you what you are doing. I think two more, we should be done with two more. Okay. So we're looking for this and that. So for this type, the area becomes so excuse me, sorry. So whatever you find on the table for this, for negative 0.87, remember the negative sign is just to tell you that it's on the left side. So don't worry about the negative, just look for 0.87. And then 1.2. For 0.87 from the table, we have 0.8 under 7. 0.8 is right here. And you're gonna go under 7. So 0.8 under 7. Maybe 0.30, my pen, 0.3078. Yeah, so 0.3078. 0.3078 plus for 1.28, we go there. 1.28. You look at 1.2 is right here. Excuse me, and you go under 8. So which is this one here. So 1.2, you go under 8. Which is, see, under 8 right here. 3997. Okay. 0.3997. 0.3997. So you add them together to get the area you're looking for. So when added together, when I go to mouses. Okay, it's working again. Just 1 minute. Okay, let me see what is wrong with this. Mouse. All right, got it. Okay, it's back. So if you add this, go to this, the calculator, you have 0.3078 plus 0.3997, you have 0.7075. So 0.7075. Give me 1 minute. $7075. So I'm gonna put right here 0.7075. Or if you like, you can call it 70.75%. Okay. So any question for me? Any question?
No.
No question. So now let's look at normal distribution as a probability distribution. So this one, when they ask you to find the probabilities for each, they are asking you to find the area. So what they're asking you here is the same thing that's here. Except that this place they use symbol. For example, the first one we did, this one, it can ask you to, another way of writing this is probability of Z less than, say, less than 1.76 equal. See? So that either they say to the left of Z or they just ask it this way using symbol. So basically this one we just did and these ones are the same. For example, if they ask you find the probability of Z, let me say less than, if they ask to find the area of Z negative 1.65 is the same as asking you find z less than 1.6, negative 1.65. So it's the same thing. So let's just do one of them. Let's say we do this one. Say solution. They say find the probability of z less than negative 1.65. In that case, you just do the same thing, draw the chart. Negative 1.65 is negative, so it's gonna be on the left side. And they are finding the probability. So you draw the chart first. Okay. Okay, we have. Okay. Okay. And then you put on the x-axis. And then you put the center line. Okay. Which is 0. And it said less than, that means it means to the left. If you said this means it means between 0 and this one. This one means between 1.46 and 2.97. So it said less than negative 1.65. So let's just put the 1.65 line. Put that. Okay, right here. And then she said less than that means on the left side is less than that. So we gotta share the left side, all of them. Okay. All right. Okay. Okay, this one here. Right. Okay. This here. This. And the last one is right here. Okay. Now on the left side, see, this is the left tail. It's what called left tail. Left tail. And remember what I told you, whenever it's at the tail, you subtract your answer from 0.5. This is the left, excuse me, my mistake. This is the left tail. So in that case, like I said, negative 1.65 is just to tell you that it's on the left side. So all you gotta do is write the probability, the required probability that you're looking for. You have it here. Probability of z, it will be equal to now you're looking for only the shaded portion, not all the halves. So all these halves represent is 0.5. The other half is 0.5. So, but for this particular left half, you're looking for only the shaded part. So you're gonna do 0.5 minus whatever you found for this area, for this at the table of normal distribution. So let's look for 1.65, 1.6 under 5. We got 1.6. We gotta go under 5. So 1.6 go under 5. See, that's under 5 right there. So it is 0.4505. 0.4505. So you're gonna write it 0.4505. 0.4505. Now from your calculator, you can get this area. You do 0.5. 0.5 minus 0.4505. Give me 0.0495. So that will give us 0.0495. Or if you like, we call it 4.95%. Questions? Any question? Query, objection? Anyone at all?
No.
Right there. So you can see that it's the same thing when they say area or when they use symbol, it's still the same thing. So let's look at how to do the opposite of that. The opposite. So say finding the specific z value for a given area. In this case, they give you the area or the probability, and they ask you to find the z. So what do you do? So for this one, see they give you the area, but they ask you to find the z. So what you're gonna do is to do the opposite. You look for the area inside the table. In this case, they said find the z value such that the area under the normal curve, normal distribution curve between 0 and z value is 0.2123. So they share the area they are looking for here. That means it's on the left, right side. Excuse me. So yeah, they find the z. So what you're gonna do? Actually, I have the answer here, but I'm gonna show you how you get it. You go to the table and start looking for this number here. So it's 0.2123. Let me write it down. 0.2123. So you go 0.2123. So this time you're doing the opposite. So you're not looking on the side, you're looking inside the table because you're looking for the z. So 0.2123. Look for 0.2123 inside this place, not from the side. So 0.2123. You can see right here. See? So you follow it to the left. Say 0.5 and up 6. That means it made 0.56. So that's how 0.56 that you see here. See, 0.56 come about. Question? Any question for this? So no questions. Good. Now, sometimes they will not give you the chart. Most times they won't give you the chart actually. So in that case, for this line, says find the z value such that the area under the normal distribution curve is 0.3460. They didn't tell you whether it is left or right. So the answer can be on the left side or right. So you're gonna use z value of any of this. So what we're gonna do is to, since they didn't tell you the direction, whether it's going left or right, so you assume that it's gonna be either left or right. Okay. So we're gonna plot. Excuse me. Yeah. So we're going to. This is what we're looking for. Let's make the chart ourselves since they didn't give us the chart. Let's assume that it's on the left side so we can get the chart what we're looking for. Then we can now, okay. All right, you got it right here. Okay. Oh, I didn't draw it right. So I'm gonna delete this and try it again. Okay. Then I'm gonna put the axis, the x-axis. So I'm gonna go down a little bit. So let me move this down so that I will have enough room for this. Okay, that's better. So this is 0. We don't know whether it's on the left side or right side. We can just assume that it's on the right side. Okay. Okay, let's assume that it's on the right side or on the left side. It can be either or. So this is the Z we are looking for. We don't know what it is. Z equals, we don't know. So now we can now look for this on the table. So what that means we have the equals. Now let's see. Now let's look for this 0.21. Actually, this is 0.3460. So let me correct it. 0.3460. 3460. We look for this on the table of normal distribution. We go 0.34. Well, let me write it down. 0.3460. 0.3460. So we look at from 3460. We have 3461, then 3468. So we don't have exactly 3460. If you don't have exactly 3460, you choose the one that is closest to it. See, 3461 is very close to 3460. Am I right or wrong? Hello?
You are correct.
So it's closer, right? So you go to the left, which is 1.0. Then up 2. So you're gonna be 1.0. Let me check it again. 1.0. See, if you follow it to the left, 1.0 up 2. Let me write it down. 1.02. 1.02. Okay. So you have 1.02. Because on left side, negative 1.02. If it's on the left side, okay. Or it can be, if it's on the right side, just put 1.02. The equation didn't tell us what direction. So we assume that on the left side, or it can be on the right side. Of course, you know that this is shaded, you know. This is shaded. You know, these are shaded. Okay, let's answer that. Now, sometimes they may give you the one that is very large, like here. They say find the Z value to the left of the mean such that 98.87% of the area of the distribution curve lies to the right of it. So you are looking for the Z value to the left, see? To the left of the mean, where the mean is 0. This thing, you know, we are 98.87% of the area lies to the left, to the right of it. So again, the main thing is to draw the curve. Okay, solution. So 98.87% means 9.9887. So we are looking for this Z value. Okay, this is solution. I'm going to put you here. I'm looking for the Z value to the left of this, so 0.9887, 9887, such that 98.87% of the area under the curve lies to the right of it. So but the main thing that Z value is to the left of it. So you're gonna be on negative side because it says to the left. So we're gonna make our chart. So this one Z will become equal. We don't know. So let's make our chart. I'll draw this chart. Okay, we start from here. Okay. All right. And then we can put our, oh, I think I missed it. Oh, it's there. Okay. So just adjust it a little bit. Okay. All right. Now find our center. Now we're looking for the z value to the left. See, or the mean. Remember that our mean is 0. Oh, excuse me. Our mean is 0, so this is 0 right here. So we're looking for the mean to the left, z to the left of that. Z. We don't know what it is. So I'm gonna put it here. Put the shape. So it's to the left. Such that 98.87% at the right. So you're gonna be this. We have it here. Excuse me, my mistake. Huh? Z value to the left, so that this one at to the right. So we are looking for the z value to the left. So you're gonna be now on this side. See now, because see, when you go to the table of this, the highest you can see if you're using this particular table is 0.4999. Anything above 0.5 is not here. But you know that this normal distribution is symmetry. And since we are doing the opposite, if it is if you are looking for the z value, I mean the area, you do, and it's on the tail, you do 0.5 minus that number. But here you are doing the opposite. So you're gonna do 0.9887 minus 0.5. Because you're looking for the z value to the left. Yeah. So I'm gonna shed it. Let me shed this. Okay. Z value to the left, so that 98.88% are to the right of it. Okay. Now, just one, I'll get it out. So if 98.87% are to the left, so we can, then this will be on the left. Right. So this place, if I'm 0.9887, then but you're looking for this z value to the left of it. Okay. Now, this gives us 0.9887 minus 0.5. You can get that from the calculator. 0.9887 0.9887 minus 0.5 is 0.4887. So we have it here, 0.4887 for 0.4887. That's what you're gonna look on the table, which should be, go to the table now, 0.4887, 0.4887. You can see it here. I think it's gonna be somewhere. Okay, right here. Now, if you don't see the number exactly, you choose the number that is closest to it. So you can follow, if you follow this to the left, you will see that it is 2.2. I go up, 2.28, 2.28. Now, you're gonna write 2.28, 0. sorry, 2.28. 8. Now, because it's on the left side, you're going to be negative 2.28. So you're going to have here negative 2.28. Okay. And that's it. So this is when you want to understand the principle behind how to use the table, or how to get the z value. Or if you don't have the z value, if they give you the z value to get the area or the probability, then that means you are getting, you're understanding what normal distribution is talking about. Now the standard normal distribution. The standard normal distribution is a normal distribution that has a mean of 0 and a standard deviation of 1. So all normally distributed variable can be, transformed or changed to standard normal distribution variable using this formula here: x minus mean over standard deviation, where x becomes the value, then the z becomes the standard score, mu is the mean, and the theta is the standard deviation. So now, so that means if they give you the value, you can transform it to a z value using this method we use here. Using this formula here, and then apply the method we used in finding the area or the probability. So that's what we're gonna do tomorrow. And then after that, we'll finish it tomorrow, and then we'll finish normal distribution, how to apply this transformation formula to any normally distributed variable to get the probability. So that will be the application of normal distribution. Starting from tomorrow, we do it tomorrow, and then round up by doing the central limit theorem. Okay. Questions before we leave? Hello.
No question.
No question.
Yeah. Maybe we can do an example. Let's do one example. Let's do one example, probably.
Okay.
So look at the application of normal distribution. So all normally distributed variable can be transformed into standard normal distributed variable. This formula here, which I explained. Let's look at them under the application of normal distribution. Is the mean monthly bills in a city are normally distributed. The monthly utility bills in a city are normally distributed with a mean of $100 and a standard deviation of $12. A bill is randomly selected. Find the probability that the utility bill is less than $70. Find the probability that it is less than it is between $90 and $120, and then find the probability that it is more than that. So let's answer this. Our solution.
I'm sorry. Can Ms. Ford please mute herself? Sorry. Got it. Thanks.
Yeah. So the first thing you do is to transform. Let's start with part A. We are told that the mean is $100. So the mean is $100. Okay, $100. And the standard deviation, I'm going to move this to the next page so we can have enough room. The mean is $100. The standard deviation is, I think it is $12. So that we have that, and our X, say for A part, say find the probability that the utility bill is less than $70. So X is $70. That's 70. So the first thing we do is to transform this X to Z, to a Z variable. Once we do that, we can now find the answer from the table. So how do we do that? We use the formula here. And we use this formula S minus mean divided by standard deviation. Okay, what we use, see? So that our z becomes, so we're gonna transform this 70 to a z value. So we have z equals, we got 70, that's for x, minus the mean of $100, okay, divided by standard deviation of 12. Okay, let me write this down so we can work it out. Z equals 70 minus 100 divided by standard deviation of 12. Now, when we go to our calculator, we can have it transformed using that calculator. We have so you have z, 70 minus mean of 100, close the parenthesis, divided by standard deviation of 12, negative 2.50. So we have negative 2.50, which is negative 2.5. So now it is no longer an x anymore. It is now a z, but it is now transformed. It is no longer 70. It is now negative 2.5. So that the probability of that the bill is less than 70 is the probability of z less than negative 2.5, negative 2.50. Because that z value represents $70. So to find out, what you're gonna do, like we did before, is to first of all draw our chart. Okay. We have our chart like this. Okay. Then we have negative 2.5. It's negative side because it's negative, so you're going to be on the left side. Negative 2.5. Of course, our 0 is the center. Now we can now put our x-axis to that. Okay, it's the x-axis. And put our center line. Okay, so we are looking for less than negative 2.5. So let's put the line that represents 2.5. You know, we are looking for less than that. So you're gonna be left tail shaded here. Okay, shade here. Okay, shade here. Bam. So next week I'm going to we'll talk about this. All right, discuss this. All right. Okay. So this is where we're looking for this part, the left tail. So the required probability for this to be, so remember, this is 1/2 of it is 0.5, but you're looking for only this part. So you gotta do 0.5 minus whatever you see on the table for negative 2.5. Remember, negative value is to show, the sign is to show you it's on the left side. So when you go to the table, you'll be looking for 2.5, not for negative 2.5. So you go to the table and then 2.5. See 2.5 is 2.5 is right here under 0. Well, this is under 0, right? Go up, you see that it's under 0. So 2.50 is 0.4938, 0.4938. Okay. You have 0.4938. 0.4938. 4938, right? And when you subtract that, you're gonna find So 0.4, 0.5, and what's that? So on the your decimals, we have 0.5, 0.5, 0.4938, 0.0062, 0.0062. Write it down. 0.0062. So that the probability that the bill is less than $70 is 0.0062, or and call it 0.62%. Any question on that? Question? Okay, so there's no question. Okay, good. Let's look at part B. Part B says, find this probability that it is between $90 and $120. In that case, you have to transform it, transform two values. Now, you have the the mean again, the mean and standard deviation remain the same because it's still the same equation we are solving. The mean and standard deviation remain the same. But this time around, you're transforming between, you're transforming 90 and 120. So let me move this to the next page so you can have enough room. So we have x1 equals 90. X2 equals 120. You know, things like this. Okay. And then x1. Okay. Now, so let's transform x1. We're going to use z1 equals, the z1 is for s1. Okay. Equals x1. I want to write the, remember the formula for transformation. So let me write the formula properly. Okay. I'm going to take you to the formula page where we can write the better formula for that. So that we have z1 okay, z1 equals x1 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 minus mean. Okay, the mean is somewhere here, divided by standard deviation, which is somewhere here. Okay. So taking it back to our main workbook. Okay, this is Z1. So this means that the Z1 is equals, we have S1 is 90. Okay, minus mean of 100 divided by standard deviation of 12. So 90 minus 100 divided by 12. 90 minus this is Z1, 100 divided by 12. So we go to the our table, I mean our calculator. So you have 90 minus 100, close it, divided by 12. Point negative 0.833. This is 0.8333. Okay. So Let me check something here. I put 70. Okay. We have 90. Okay, 0.8, negative 0.833. That means 0.83. So we're gonna make it 0.83. 0.83. About 2 decimal place. Then Z2. For Z2, we do the same thing. That's for, that means Z1 is not, it is S1, it is no longer 90 now. It is now negative 0.83. Now let's transform X2. For that, we're gonna use go to our formula workbook. X2, Z2. It's going to be here. Okay. Z2 equals X2. So I'm gonna put it here. Okay. And put this in our main workbook. It's gonna be like this. That's our formula right there. Now, so that means this is gonna be that our Z2 will now becomes, okay, equals 120 minus mean of hundreds divided by standard deviation of 12. And that will give us, if we go to our calculator, we change this to 120 here, 120. 1.666, I mean it's 1.67, 1.67. 1.67. So it is no longer a 129, it is 1.67. So it is now, it's no longer X2, it's now Z2. So that the probability that the bill is between $90 and $120 means probability between Z1, which is negative 0.83, less than, okay, less than Z, less than 1.67. 1.67. So it means that the probability of between 90 and 120 means between negative 0.83 and 1.67. To answer that, we can draw our chart. Okay. All right. All right. Oops, I messed up. I messed up. I'll do it again. All right. All right. Now I'm gonna put the horizontal axis. Okay. Then I'm gonna put the middle center line, which is the 0 part of the mean. Okay. This is a 0. So between negative 0.83, I'm going to put the line that represents 0.83, which is right here. Negative 0.80. Okay. I'll move this to look back a little bit. Okay. And 1.67. All tired, huh? 1.67 should be around here. Okay. 1.67. So between them. So between them will be to share between them. So we're going to share from here. All right. That's the area probability you're looking for. Right there. Okay. The second part is right. Okay. No, on paper, this is much easier on paper than using a graph like this. Okay, let me complete this. Now, last shading will be the last line I'm gonna put. Okay, so between them. So that between, this present between 90 and 120. Okay. So now the probability now becomes, we find for 0.83 on the table. So we got to do for 0.8 under 3. I'll go to the table and look for 0.8 under 3. 0.8, you go under 3. It's right here. As you can see the 3 at the top. So 0.8 under 3 give us 0.2967 plus the second part is so what I write is 0.2967 plus then the other side is 1.67, which represents 120. 1.67. You go to the table. 1.6 under 7. You can see 1.6 right here. So you go under 7. Okay, see 7 right there. So 0.4525. So 0.4525. 1.67. Okay. 0.4525. So when you add these two, that will give you the required probability. So you have this 0.2967 plus 0.4525 get 0.7492. So you have 0.7492 equals 0.7492. See, questions on this? Any question?
No.
No.
Good. So now,
No.
good. Now, part 3, part C, you can try part C as a practice at home. So we will end today. From tomorrow, we will start from this place, finding data values, giving probabilities, and then we'll finish normal distribution tomorrow. Now, next week I will put test 2, and then upload. I think I've already uploaded the question for the project, but if I haven't, I will try and put them in there to this weekend, so you can start working on them, and then prepare for your final test. Any question before I call your names?
No.
All right. Miss Rita, are you there?
Say it again.
Are you there?
I'm here.
Send my email. Send your email.
I ain't seen you email.
Huh?
I didn't see the email.
Check it. You gave me your personal email. Did you check there?
Yeah. I received it. Yes.
Okay.
Yes. I got it. Thank you.
You're welcome. Now, Miss Beast, are you there?
I'm right here. Have a great day.
See you tomorrow then.
All right.
Miss Debbie. You there?
Yes, sir.
Takia. Takia is here. I saw Doll is here.
Yes, I'm here.
So Donson here. Taiji Ken. Miss Ken.
Yes.
Vanessa is here.
Yeah.
Who else? I think that's what I have here.
Have a good night.
Miss
I didn't
Walker.
hear my name. Oh, yeah, I'm here.
Walker, are you here?
Yes, I'm here.
Who else? Keshona. Keshon is here.
Yes, I'm here.
I have everybody now, right? Yeah, that's Keshon is the last person. Yep, and Vanessa is here. So that's what I got.
Correct.
All right, see you guys tomorrow.
Was here.
Okay.
Okay.